This video is a solution to the collision problem that I assigned this past week for my AP Physics students. The problem reads as follows. We have a 10 kilogram mass that's approaching a stationary 5 kilogram mass. So let's go ahead and draw these. This is the 10 kilogram mass. It's approaching it at a speed of 2 meters per second. It's going to strike this 5 kilogram mass like this. And after colliding, so this is before the collision, and then after the collision, we are told that the 10 kilogram mass has slowed down to a speed of just 1 meter per second after the collision, and we're asked what is the speed of the 5 kilogram mass after the collision. It's got some unknown speed, we'll call it v. Okay, well here you probably realize right away that this is a conservation of momentum problem. So the momentum of this entire system before the collision is the mass of the 10 kilogram object, which is 10 times its speed, plus the mass of the 5 kilogram object times its speed. So that is just going to be 20 kilograms meters per second. Well, that has to be equal to the momentum of the entire system after the collision, which is going to be the 10 kilogram mass times its speed of 1, plus the 5 kilogram mass times its speed of v. So we need to say these two are equal to one another. So when we do that, we can say that 20 has to be equal to 10 plus 5v, or 10 equals 5v, or in other words, v is equal to 2. So we've just found the velocity of the 5 kilogram mass after the collision by using the principle of conservation of momentum. The second problem that we're asked is what is the kinetic energy before and after the collision, and is it conserved? Well, the kinetic energy before the collision is going to be 1/2 the 10 kilogram mass times its velocity squared, plus 1/2 of the 5 kilogram mass times its velocity squared. Well, we can figure that out quite easily. 2 squared is 4, times 10 is 40, divided by 2 is 20. Well, that's kind of nice, it worked out the same. 20 joules of kinetic energy before the collision. What about after the collision? Well, it's 1/2 times 10 times 1 squared. I'm again using 1/2 mv squared for kinetic energy, plus 1/2 that mass times its velocity squared. So this first term right here becomes 1/2 times 10 times 1, which would be 5 joules. And the second term becomes 2 squared is 4 times 5 is 20, divided by 2 is 10, so 10 joules. So there's a mere 15 joules of kinetic energy after the collision. So some energy has been lost. Well, strictly speaking, the energy we anticipate is not lost, it's turned into heat. This is an inelastic collision because the kinetic energy before is greater than the kinetic energy after.